This week we'll be covering the operators and expressions in Python. So this will be now a combination of the notion we have used last week, so we can proceed further and put everything together for you to be able to write more sophisticated and complex code. In Python, like other programming languages, we have operators, okay, which are used in general to perform operations on variables or on values. We have seen last week the notion of the variables. The variables are just containers that are used to memorize values in memory in order to perform on it some operations. So in Python, we don't have a specific declaration of the type of the variables. So the variable type will be explicitly defined by the value that will be initialized to the variable at the usage. Okay, so you don't need to define any type in advance. But if you want to fix a type for a specific variable, you can use the casting approach, as I explained last week. You can fix the type that can be saved in a variable by casting the type. We have several standard symbols that are used to make operations in Python. So we use basically the logical and arithmetic operations. Okay, we have several symbols that we already know. For example, for operators, we have the plus, minus, plus, multiply, and the division symbol, which are used for performing some arithmetic operations on the values or on the values stored in variables. So for us to make an expression, we have also to use operands. Operands are referred to the values or variables on which we perform operators, okay, operations. So those are key concepts I wanted to explain before I begin with how to make an expression, okay, in Python. So an expression is just a combination of values, variables, operators, or function call, okay? Those are the components that are used to make an expression in Python. And then this expression should evaluate and produce the results. The result should always be assigned to the variable that will be placed to the left side of the equal symbol, okay? Here we have a few examples of Python expressions. Like this, you have an arithmetic expression that is saying to take two values and produce the sum of those values. So these are known as arithmetic expressions, like 3 plus 5 equal 8. Here, 3 and 5 are operands. And then we have the plus, which is called operator. We can combine also operators together and operands, like in this expression, you have A. A represents a variable. B also is a variable with a value 4, okay, an integer value. So using variables also, we can make some expression. This expression mean take the value stored in the variable A, multiply with the value which is stored in the variable B, and then deduct minus 4. So you can reduce from that results 4 as an integer number, okay? I mentioned also that in an expression, we can have functional call. A function is just a subroutine or a sub-program which is used in a program to perform specific task. Like this print. Print is a built-in function in the Python, which is used to print out the result to the user using the output interface. Like this instruction is using the print function called to print on the screen Python as a string. So here are three examples of expression statements. Let's see now how an arithmetic expression can be formatted in Python. Okay, most of the time we have the expression on the right side, as I mentioned, that can combine operands and operators. Like here, we have two operands, 3 and 5. They are integer values. And then we use an operator which is plus. Then we have one more operator, which is the assignment operator. The role of the assignment operator means take the result of the expression on the right side and then save it in the variable which is placed on the left side of the assignment operator. So this is the way the Python interpreter will understand this expression. Always we will have a variable on the left side to save the result of the expression which is placed on the right side of an arithmetic expression. Okay, so remember that we always use the equal as operator in Python. In order to check whether two variables are equals, in that case, you have to use double equals like this. This will be used to check the equivalent between two values, okay? So now let me remind you some vocabulary of the algebra you already know, because we'll be using those terms throughout our class. So here I will explain the key term that are mainly used in algebra. I already explained the expression. I will explain the meaning of an equation in the context of algebra, and then the concept of variable, the term, the coefficient, and then a constant. Because we have to understand this term in order to be able to understand any problem when we have to use our computational thinking to resolve a specific mathematical problem or represent any problem which can be given to us mathematically, okay? So the term like here, which is shown in the green color, in algebraic term, it's a number or a number multiplied by one or more variables. So this is what we call a term. So you can combine here, everything in the green color in this equation represent a term, which can be a number or a combination of a variable with a number, okay? Like here, you have a number 52, which is multiplied by variable x to the power of 2, okay? So this is the meaning of a term in the context of algebra, okay? The expression is a combination, okay, of terms with operators, okay? Like here, we have one expression on the left side and one expression on the right side. We have terms which are combined with operators. You have minus, plus, so this make an expression. And then you have another expression on the right side. So let's see now a coefficient. In a term, you can have a number which is multiplied by a variable. So the number most of the time will be referring to a coefficient. So it's the number which we use to multiply by a variable. So that number, it's a part of a term. and it's referred to as a coefficient. Next is a constant. A constant is just a number which is not combined with variable. That means it doesn't depend on any variable. Like here, you have 82. 82 is a constant number. That means it doesn't have any variable, okay, influencing the constant. So it's just a number which will not change. You have this one, 82 and 36. They represent constant in this equation. Now let's combine everything. So those two expressions, one on the left and the other on the right, combined with this equal sign, represent an equation. An equation is represented by two expressions, one on the left and one on the right, with the equal sign. That means it tries to check the equivalence between the expression on the left side, whether it's equal to the expression on the right side. In this case, the equal sign does not mean assignment. Do not be confused. In this case, the equal sign, it's used to check the equivalence between the expression on the left and the expression on the right side in the context of algebra. While in the Python, the sign equal will be used for assigning the result of the expression that will be on the right side to the variable that will be located on the left side. Okay. So I hope it's clear so far. With that said, I will be now elaborating on the types of Python operators. Okay. In Python, we have many types of operators that can be divided in 7 types. The first one is the type of operators I've already mentioned. They are arithmetic types. The second also I already mentioned, we have the assignment operators. And then we have the third one is the comparison operator. The fourth is the logical operator. And then the fifth is the type of identity operators. The sixth one is the membership operators. Then the last one is the bitwise operators. So I will be now going through each type of operators and then show the use case in Python and give you some example for that. Let's start with the arithmetic operators. They are the most used one. So these arithmetic operators are used with numeric numbers, okay, to perform common mathematical operations. Like the addition, we use the plus sign. To do the subtraction, we use the minus sign. For the multiplication, we use this star, okay, sign for the multiplication. For the normal division, we use just this slash. For the floor division, we use slash slash. Floor division means it will only return the entire part of the results without considering the decimal part. So only the integer part will be returned without giving the decimal part of the result. Then we have this one percentage, which is used for the modulus, is the division that return only the remainder of the division. Star star will be used for the exponentiation. So to do exponentiation, we use star star in Python, double multiplication. Like a normal addition expression in Python, you can do an expression directly on numbers, like here, 5 plus 2, that will give you 7. Or you can also use variables. So I will also try to show you how you can run those expressions and use the operators directly in Python interpreter. So I have this Python interpreter. I have the terminal shell interface for the Python. So I can do arithmetic operations like this, 5 plus 2. The interpreter will understand exactly what does this expression mean. I can also do that for the subtraction. 5 minus 2 will give me 3. Or 5 multiplied by 2 will give me 10. So the interpreter will understand as if, okay, you are the one doing such kind of operations. 5 divided by 2 will give 2.5. Now look at the floor division operator. 5 using the floor division symbol divided by 2 will give me only 2 without the decimal part. Okay. Depending on the results you are looking for, you have to choose the right arithmetic operator to get the expected result. You have also the modulus. This one will only give us the remainder, okay, of the division of 5 by 2. And then I will use the exponentiation. 5 to the power of 2 will give me 25. So those are just simple arithmetic operations. You already know how to do that. So you can also directly show the result within the function call. Like we already seen how to show the result using the output instruction in Python. The output instruction is implemented in the built-in function, which is print. So as you can see here, while just using the interactive mode, the interpreter can give me directly the result. Okay. But if you are not using the interactive mode, for you to get the result out, you have to use whether variables or directly use prints to show the results. If you use such kind of operations in your code, okay, without running the interactive mode, okay. For example, I'm using VS Codes. Let me illustrate what I'm saying so you can understand. I make a new file that I will call operators dot py. Okay, this is my program. So inside, I just mentioned this. Those operations I just run on the scripts Python interpreter. Now I will put that in the Python file, okay, to make a script just to show you the difference when you run that on the Python interpreter interface. So, like this, I have this Python script which is made of 6 arithmetic operations. Okay, if I just run this program like this, you will see I don't have any outputs which is given to me. Okay, no outputs. Why? Because they are expressions. Okay, the Python interpreter will calculate the result for each expression, but since I don't save that result anywhere, I cannot receive any output from this program. But for me to address this issue, I have to use the prints. Okay, the printer, the prints function call and I will provide the arithmetic expression inside the print. Okay, let me comment this, and then I will show you how this will be different when I use print. Because when I use print, I can directly collect the result and show that on the screen of the user. But the result will not be saved in memory. So it will directly perform the expression and then provide the result directly on the screen without saving the result in memory. For that, we will need to use variables. So I'm doing this because I want to show you how important are variables in a program. They help you to keep the intermediate result of your program for you to use them later, okay, when needed. Now, if I run this program again, you will see the results on the screen. Okay, I'm here. I go to this play button. You will see now it's give me the results. I have 7, 3, 10, 2.5, 1, and 15. I hope it's clear. You get the points. Okay, the point is to show you when you need to use variables. Okay, at this stage, I showed you how to use arithmetic operations in Python. If you want to get the result directly, use print, the built-in function to output the result. But if you want to store the results in memory, in that case, you have to use variables. So this will lead me to the third version of this program. This is second one, using print, okay, alone. Now I will save the results in I will save the results in variables, and then so I showed you how to use arithmetic expressions, and then now I will show you the third version, how to use variables. Okay, let me comment this. I will note to comment several lines I mentioned last time. You put triple quote like this. So when I put triple quotes, I will comment everything here. Okay, you can see this parts of my code will be ignored by the interpreter. Okay, now I will do the same. I have just to take all those expressions here, and then I will assign the results to keep these results in a variable. And then I will take B that will be used to save that results in memory. So as long as I keep that result in the dedicated variable, I will still use it anytime because it will still be in memory. I have A, B, C, D, E, F. Okay. Now I can now use prints to access to those variables, or just call the name of the variable. So I have 6. Now in print here, I want to access to the contents of A, B, C, D, E, and F. Okay, let's now try to run this program. So the other way to run the program, I've explained, you can use the Python instruction with the name of the scripts. be sure you are located in the folder where you have saved the file, like this. It's the equivalent of running the program by using this play button. When I run this instruction, you can see, in this case, I can still access to the result of those expressions which are stored in the variables A, B, C, D, E, and F, okay? So I hope it's clear now. The variables are used to save the result of mathematical expressions, okay? So far, I've explained how we can perform arithmetic operations on integer values. We can also perform operations on floating point decimal numbers, okay, which are referred to as floats in Python. This is a type of floating point decimal numbers. So in Python, if one of the operands is of type floats, the result will be also given as floats. Like you can see here, 7.5 plus 2.5, the result will be also in the decimal point floating format. So this will be 10.0. When I do minus, also it will be representing the results with the decimal points. Same for the multiplication, the division as well. This floating division and the modulus as well. So let's try that using our scripts. I will be using this Python script file because I will be needing to reuse the same code, because if I use the interactive mode, it will be difficult for me to reuse that. Okay, this will be now using the float type. Okay, so I will use the same approach. I have 7 dots 5 plus 2 points. So in Python, okay, when you do expressions, if you stick the operand, the operator, and the second operator like this, it will still be working. Let me show you here using this. I have, for example, 7.0 plus 2.0. The interpreter will be still understanding, although those two operands are concatenated with this plus. It's better for readability to put space, okay, between the operand and the operator, so it will be clear to read like this. So 7.5 plus 2.5 will give 10.0. Okay. Same for the remaining operations. If one of the operands is of decimal points type, the result will be also a decimal point type number. So you can still use them also with the prints to show directly the results. If you just use the expression like this, this will not be showing the result in the script program approach, but it will be showing the result when you run that at the Python interactive shell modes. Now let's see the next use case of operators. You can also perform some operations on variables, because we know that variables are used to keep values in memory. So when you do some expression using arithmetic operators on variables, This will tell the interpreter to take the contents, I mean the number which is stored in this variable, that will be computed considering the operator connecting those two operands, like A plus B. In case A have been initialized with 20 and then B with 6, this will give the result of this A plus B expression as 26. Like we can check it here. First of all, you have to initial. Let's say, for example, I have A, okay? When I'm just using this expression like A plus B, what will be the result of this expression? It will give me an error message. Why? Because A and B are not defined as a variables. In Python, we have learned that the variables are defined at the declaration step. When you use a variable and you assign a value, automatically the variable will be defined. So let me now initialize A with 20 and then run again the expression A plus B. You will see in this case, A has been defined here with this initialization expression, but B still not defined yet. I have to initialize all the variables before I use them in an expression. So I have also to initialize B with 6. Then when I come, I run this expression, A plus B, it will give me the result. Remember again, I get the result because I'm running the instruction in the interactive mode. If this expression is given in a Python scripts, I will not get the result anymore unless I use the appropriate instruction, which I will show you. Here we have to use prints to get the output of the expression of A plus B. I'm still repeating this because it's very important. If you miss that, you may not get the expected behavior of your program. So be sure to use the input and output statements when needed. Same for A minus B, because I already initialized A and B. Now I can use the minus with prints. It shows me the result of A minus B. I can then use another operator like multiplication here. It will give me the multiplication of 20 by 6. Then I can try another one here. The division, I will divide 20 by 6, which will be giving the result with the decimal parts, okay? Precision, with high precision. Then if I don't need to get the decimal part, I only want to get this integer value of the results, I have to use 2 / the floating division. The floating division here will give me only 3 as a result. So depending on the specification of your program, you have to decide which sign to use. If you don't need any decimal point details, use the //. If you only want to get only the remaining of the division, use this modulus. It will give you only the remaining of the division of 2, the content of A and the value stored in B. Same, you can also use A. Use the A to the power of 2. You use A ** 2. It will give you the result of the value stored in the variable A to the power of 2. Okay, I hope it's clear so far. Do you have any question before I go further? So the same thing can be also applied on the float variable type. Float variable types are used to represent numbers with the decimal parts, where you have the integer value, the point that separate the integer, and then the decimal parts. So this type of values are stored in a variable called the variable of type floats. So I've shown you last time how to get the type of a variable. So as I mentioned earlier, when you do operations on the values of float type, if one of the variable type is float, the result will always be float, like this with the decimal points. We can now try to use those arithmetic operations in a real world example. Like when you have a rectangle like this, that has its specification. You say this size is 15, and then the side of this white is 7. When they ask you to calculate the area of this rectangle, so for you to write a Python program that can perform that, first of all, you have to define two variables to represent this value and this value. Then this area will be the multiplication of this value with this value. So this is the way you can resolve this question and then write the Python program. So let's try that within a Python scripts file. I use here my Visual Studio Code. You can still using notebook using Anaconda as well, but it's up to you. I've explained all the possibilities for you to run Python program. You have to choose the one which is convenient for you. So I use VS Code because it's convenient. I can make files easily. So here I will make a new file that will be compute area. This is the name I give to my program .py always, okay? Then this gives me an empty Python script file with the extension .py here. So after writing my algorithm of the problem that has been given to me to write a Python program that will compute the area of a rectangle, I have already made my algorithm. What will be the instructions? Okay, in my algorithm, I say I need at least two variables. I have one variable that I call length, and then the length will be initialized with a value of 15, and then the width will be the second variable that I will initialize with 7 because the problem statement has already given those values. Okay. Then to calculate the area, I use another variable that I will use to store the result of the expression that I have already figured out in my algorithm to compute the area of a rectangle. This is the expression, is a statement. Here I have an expression where I multiply the length with the width, and then I use the assignment operator to assign the result to the area. So whenever I call this variable area, so I will access to the result which I have saved in memory. So now I will use the print instruction to output the result to the user. Okay, area of rectangle, then comma, here I will use the variable area. Okay, here is my Python program. Then I will run to check whether it's give me the expected output. Okay, to test it, I run on the play button. Okay, it's work exactly. It's give me the area of the rectangle. So which is the product or the multiplication of the length with the width. So whenever I will use the area, let's say I will also call again area here down. You will see always I will be accessing to the content of the variable because it store the data in memory. You can see here, whenever I call that, I will be using the same, I will be receiving the same results. So I can call that several times. Let's say print here several times. Whatever I will be printing, I will be receiving the contents of the area. Unless I update the value. Okay, if I use this variable to assign a new value, it will be overriding the value of the expression I've calculated before. Okay, let me show you with an example. For example, here after calculating the area, I will update the area. I say here area should be taking the value in area. Okay, and then I will multiply that by 2. I will double it. Okay, this will be the double of the area. So with this program, I save it always. When you see this mark on the top, this sign, it shows that this file is still not saved yet. You have to save it. If you don't save, you will lose all the latest updates. Okay, if you close it. So let me come back to this example. So after saving the result of this expression in this variable, whenever I call the variable, I can access to that value. So if I assign a new value, I will override the previous value. Okay, when I run this program, you will see now it gives me the normal area value and then the double one. Okay, be sure when you manipulate the variables to not lose any of the data which is useful for your business logic of your program. So this is very important when you manipulate variables because they just help us to keep data temporarily. If you update the contents, it will be updated. So same thing can be also done with a mixture of variable type. We have here A, which is initialized with 10, okay? And then B is initialized with a float type number. So when you try this operation, the result will be of type float. As I mentioned, if one of the expression is float type, the output will be of type float. Like here, I will initialize again A. In A, I have 20, you see? If I assign a new value, this is the new value which is stored in A, is 10. Then B, I will assign 2.5 in B. Then the results of the summation of A plus B will be of type. Before I do that, let me first show you the type of A and B. To get the type, I mentioned last time, you just use the keyword type as a function and you provide the name of the value in parentheses. You can see here A is of type integer. I will check also the type of B. B is of type float. So now let me calculate the sum of A plus B. This is a statement, an expression, okay? This statement or instruction in Python whenever I want to get the result of that expression, I have to call the print function with the name of the variable to access to the value stored in the variable. So a plus b give me 12.5. Then to get the type of that results, I can just directly use type function inside print. So it will be also providing the type. I can use type alone with the name of the variable or inside print. So the effect is still the same. So remember that it's very important for type manipulation. So far, I've mentioned the normal arithmetic operators. In Python, we have also another way to represent unary operators, okay? Like when you have to write an expression like x, okay, equal 5. This is an assignment in Python. But if you wanna write an expression like x, which is equal to x, okay, plus 2. So here I have inside x, I have 5. This will be 5 plus 2. Python will understand that. So instead of using this full expression like this, Python give us some shortcuts, okay? So instead of using the full expression like that, you can use the unary operator, okay? For this expression, it's equal, it can be written like you have in x, you can write plus 2, plus equal to. That means you take the value inside x, and then you have to add 2 to the previous value of x. Like this, x plus, let me show you here down, so you can understand that's correctly. So instead of writing the full expression here, the same expression can be written in Python as x plus equal 2. This is the same thing in Python. So this is an expression which is using unary operator. So I'm using a unary plus operator. Same, I can also use a unary minus, okay, operators and so forth. All those arithmetic operation we have seen, they can be used in the unary fashion. So here you have the operator like plus equal, mean you take the value of the variable plus the value that will be placed on the right side. So this means you take the previous value of x and then you add this number. That means it will override the previous value. Like here, before I had 5, if I use x plus equal 2, it will take 5 plus 2. When this instruction is executed by the interpreter, the content of x will be 7. I hope it's clear. So these are called unary expression. Okay, let's see that here with the Python interactive shell modes. So I have x, which is initialized by 5. And then if I call 5, you will see x as the value of 5 stored in it. When I use x plus equal 2, and then I call x, you will see now x will be updated as 12. So this is the same expression like x equal x before plus 7. But if I run this expression, it will be adding 7 again on 12. That will be 17. So this expression x minus equal 2, it will take the content of 7 of x, which is 12 now, and then we'll deduct 2. If I run this expression, I call again x, you will see the value will be updated as 10. I can also try the multiplication. This means I take x multiplied by 4. So when I do this, I call again x, it will be 40. I can combine that directly in a print. Okay, print, inside a print, I have a unary expression for x divided by 2. This will be printing this message. Okay, because in this case, this unary operation, okay, for the division and this one, I will elaborate on it, you'll see. You have this one. You cannot use that directly in a print, because in the print, if you use directly the unary expression in print, the interpreter will be confused. Okay, for you to print the result of a unary expression, use a variable. Like this, I've used directly the unary expression at the interpreter directly, so separately without using print. If I would like to use print, I have to use, for example, an expression, okay, to which this operation will be assigned and then keep the result in another variable. Then at that time, I will be able to use print, not using directly a unitary expression directly in a print like this. It may give you some error messages. So with that said, I will keep going on. I have also the x divided using the division, the floating division in its unary form. This will give me 10 in this case. Okay, it will give that result. And then I can also try with the modulus of 3. When I call x, it will give me 1, the remainder. Same also for the exponentiation. This give me 1 to the power of 2 will give me 1. I hope it's clear. So always use the equal sign to implement the unary expression of arithmetic operators. So this is called the post assignment. So you take first the value inside the variable, then you do the operator considering the other operand, which can be a variable or a value. So here I've used just constant values. I can do that also with variables. It will work as well. So I've explained everything about the arithmetic operations. Now I will explain about the logical operators, okay, which are used for comparison and checking the relationship. In the algebra, you remember I explained the equal sign was used as a comparison operator. But in Python, we use the equal as an assignment operator. So for us to use now the comparison operator equal, we need to double equal sign. This means I will check the value of the operand on the left if it's equal to the value of the operand or the variable on the right. This can be a constant number, it can be a variable or an expression, as I've mentioned earlier. You can test the equivalence of the expression on the left if it's equal to the expression on the right. The comparison operators will always return Boolean type values. whether it's true or false. In Python, true is implemented as 1 or 0. You can use 0 for false. So this is the same thing. It can be also interpreted as 1 or 0. For not equal, you just use the exclamation points before the sign of equal. So this will mean not equal. So I would like to check in this expression whether 3 is not equal to 4. Since this statement is true, the result will be true. If you want to check whether the expression on the left side it's greater than the expression or the value on the right side, you can use this sign. It will give you true if the statement is verified. Less than, you just use this sign. This one also will give you true if the statement is verified. If not, it will give back the result as false. If you want to check greater or equal, you use the combination of this greater and equal sign. Do not confuse with the unary operators, okay? The unary operators are applied only for arithmetic operators, okay? Plus, minus, division, multiplication, and so forth. But here, they are used for comparison to check the relationship between the value or the expression on the right with the value or expression on the left side. So do not be confused about that. If you would like to check the less or equal, use this less inferior symbol with the bigger, with the equal. So I will show that quickly within the interactive mode. When you check 3 equal, if 3 is equal to 3, it will give me true. This means this statement, this is a full statement, okay, to checking the relationship between this value, okay, on the left, on the right, if it's equal to the value on the left. Okay, this can also be an expression. For example, let's say I have x, okay, plus 3. I'll check whether x plus 3 is equal to a plus 3. Remember here, it will work because I'm still using the shell, okay, interface. I already previously initialized a and x. If you still didn't initialize x and a, it will not work. But in this way, in this case, it will work. I would like to check whether this expression is equal to that expression. For this expression to be true, a must be equal to x, right? Okay, let me check. When I run this, you will see it's false because in x I have 1.0 and in a I have 10. So the statement is not true. So it was just to show you that you can use values or expressions to check that. The next type of logical operators, they are used for combining statements. I've shown how you can check one statement. In case you wanna combine several statements, you can use the AND operator, which is used to return true if both expressions are true. Like x is greater than 3 and x is less than 10. So if this one is true and that one is true, the result will be true. If one of those expressions is false, so the result will be also false. Or is a logical operator which will always be returning true if at least one expression is true. You can chain several expressions. If at least one expression is true, the result will be true. In this case, I have two expressions. This logical expression is trying to check the relationship between x and the value of 3. Is checking whether x is less than 3 or x is bigger than 1. So we would like to check if the value of x is in between 3 and 1. Okay. If at least one of those conditions are verified, the result will be true. In case of notes, this will return the results which will be false if the result is true. It will be the reverse, okay? Like here, notes x greater than 5. If this expression is true, the result will be false. If the expression is false, the result will be true. In this case, we have a compound logical expression that use AND as an operator. For this to be true, all those statements need to be false, false. If we have false here and then false here, then the result will be true. If it's true, true, the result will be false. I think it's clear. Okay, let me check that with this. I have one expression like here I have x, I assign 5, and then I would like to print this time whether x is bigger than 3 and x is less than 10. Okay, this will give me true because this is verified. X value is 5. 5 is in between 3 and 10. Okay. I can also check or. In case of or, also it will give me the same results because at least one of those expression is verified. Okay. Then here I will change this time. Instead of using the normal one, I will reverse the result using notes. So here I have a compound, okay? I composed the logical expression like this. I have this one will be true, this one also will be true, and then the result will be false because I change it with notes. When I run this, it will give me false. But if I put or here, you will see how it will be. It will be also false because with or, at least if one expression is verified, the result will be true. Automatically, when I will meet this note, it will be doing the opposite. So let me try this now. I have ends. I will use end. And this time I will use here. Instead of 10, I put 5. I would like to check whether x is in between 3 and 5. This one will be true because in this case, I have this expression, which is false. And because one of those two expressions is false, then the result will be false for this combined logical expression. And then I will put the not operator that will change the false in true. Is it clear?
Yes, Professor.
Yeah, if it's not clear, please ask question. I can elaborate more. So now I will also elaborate on the next type of operator, which is called identity operator. So the identity operators are used to compare objects, okay? Not if they are equal, but if they are actually the same, okay? Or if they exist in a variable, like is or not. In this case, the nots we have seen in the previous logical expression does not have the same meaning with this note. In that case, it was just trying to give the opposites, okay, of the result of the statements. But in this case, it will be checking whether the expression is verified or not. So in this case, for example, is will return true if both variables are the same. If x is y, that means if they are the same, this will be true. It will be like the equivalent of x equal y. So this is almost the same meaning, okay? note in this case, it will be equivalent to this one, okay? They're different. X is not Y. We are checking whether X is different to Y, okay? This is the identity operator. For example, I would like to check whether X is equal to Z. In X, I initialize a list of objects: fruits, apple, banana. Okay, they are objects. And in Y, as a variable, I save a list of objects that contain two objects, apple and banana. I would like to check whether uh, X is Y. Okay. At this stage, let's ignore this one. Okay, before. But if I put this instruction, print X is Z, what will be the result? What could be the result? Let me make a new file. I put identity identity operator.py. Okay, I have here X. In X, I assign a list of objects. Objects are fruits. Okay, I put inside apple and then banana. Okay, then I copy this and then I will assign the same thing uh, to another variable that I will call Z. Okay. Then here I would like to check whether Z is equal to is X is Z. I put Y. Z. Okay. Okay, let me run this. You will see the output is false. Okay. Why they say the output is false? Because here I have two objects. Okay. I wanted to explain the role of this statement here. Okay. The role of this statement. Set equal, when I put set equal X, so I assign the content of X to Z. Then when I run this, it will give true. Okay, you get the point. So this was a way the identity operator can be used. So before that object, I have mentioned in memory, the content was not the same. After I assigned the content of X in Z, it gave me true because the object were the same. This is the equivalent of this X equal X equal, for example, if I do this, now I have Y, okay, Y, and then I take this, I will print, in this case, if X equal Y, then run the program. You will see here it's still giving me false because it didn't found the content of X and Y equal in memory. And then when I use prints, this is the equivalent of X equal X. I'm not inside. I'm not inside. I will print x equal y. I should be inside the Python script or on the Python shell modes. You will see here, I would like to elaborate on the difference that can be found between the equal depending on the nature of the object. Here, I have a list of objects. When I use is does not have the same meaning as equal because you can see the list here contain the same object. When I use is, okay, when I use is, it gave me false. This is because of the encoding of the objects in memory. So at least is can be used to check whether an object is inside the list. I will show you later. But for you to check whether this list is equal to this one, you can use this operator. You can see it gives the right result. But I was expecting also this one to work as if I use equal, but depending on the nature of the objects or the value, okay, which is stored in memory, I didn't get the expected result. So this is to tell you the importance of the choice of the operator when you are building your business logic. So I was expecting something, but the interpreter didn't understand what I was expecting because I didn't do the right choice of the operator. So be aware of that. And then in the case of membership operator, you can also get another type of operations. So in is used to check whether a value exists in an object, like a list. Like I have a list of objects that contain the names of fruits, as I've mentioned earlier. In X, I would like to check whether X variable that contain the list of fruits contain the name of orange, for example. I will check whether orange is in X. So like here in X, I will check whether X is in Y. So for this expression, it will return true if the objects is existing in the variable on the right side. Not in will give basically the opposite results. So it will be checking whether it doesn't contain that object. If it's contained, it will give the opposite results. So for example, here, in this example, I would like to check whether banana is in X. Okay. When I check here, I will just try to use this. I will just comment this one so will not be confused with the results. I will now print this one. I print. I will check whether banana is in the list that is stored in the variable X. When I check this, you will see the result is true because banana exists. If I put not in, I save, and then I run again, it will give me false because banana does not exist in the list of the objects. Right. Now, this is the last one, which is called bitwise operator type. Bitwise operators are used to perform operations on bits. Okay, as we have learned in the first session, that in the classical computers, information is represented in terms of 1 and 0, which is binary representation of information. So for doing operations on numbers which are represented as 1 and 0, we use bitwise operator. because the operations on the bits is totally different on the operation we are doing on the decimal numbers. So I will quickly remind you the system numbers which are mostly used. And before that, I want cover the bitwise operations. So for the bitwise operations in Python, it convert the operands, okay, into binary form, and it return the results. So this is what it does. So the bitwise operators are used especially for low-level programming. You remember when I was explaining the difference between the compiler and the interpreter. I mentioned last time that the compiler is used to convert the code source in low level language, so which is close to machine language, so it can be easily understood by the microprocessor, while the interpreter does that at the runtime, line by line. So for low level programming purpose, so the program is always converted in binary format. So these bitwise types of operations are very useful for such kind of low level programming. It is also used for networking, because when we use the network, the information at the network level are also represented as binary formats. Okay, so for the network based program, they need to process the information which is exchanged between nodes at the network level in the binary format. So for network equipment to be able to process such kind of information, they do bitwise operations. So bitwise operators are very useful. In another use case, we have the cryptography. The cryptography is a technique which is used to hide information. So we can use bitwise operations to write some cryptographic program that can be used to hide information and protect the security and privacy of the data. In the last case, so this is useful for designing low-level algorithm that can be powerful, because they are not going through several processes like compilation or interpretation. They can be directly processed by the microprocessor. So in terms of bitwise operators in Python, here's the summary of the bitwise operators. You have this sign, which is used to represent the AND operator, which can also be represented at the physical level using electronic components. So this sign, it represents the logical operator on the binary digits. So it sets each digits to 1 if both are 1. For example, if you have a value which is stored in X, and then you use this AND operator, uh, Y, this will take all the 1 bits, okay? And then will be giving the result by doing the logic I will explain. This uh, symbol is used for OR. Okay, this straight line is used for OR logical operator on the bits. So it sets all the bits to 1 if 2 bits, okay, is 1. One of the 2 bits is 1. It's like the OR expression we have seen. You have this one also is used for XOR. XOR, it sets bit to 1 if only one of the bit is 1. So the expression is you have an operand, and then you have the operator, and then the second operator. You can combine them, okay? Making a complex expression. You have this notes is used to invert all bits, okay, and return two complements. And the syntax to use it, you put this notes symbol at the beginning of a variable. You have also this zero field left shift. You use uh, superior symbol, the one we use in the logical expression as testing greater values. So you can use this combination to implement zero field left shift. So the zero field left shift is shifting, okay, left by pushing zeros in front of the right, and then the leftmost bit fall to off. Okay, the expression is you have one variable and then you have the symbol of the zero field left, and then the value of the bit that need to be shift to the left. The right shift is taking the sign right shift bits. So it will take uh, the shift of the rights by pushing the copy of the leftmost bits in front of in front the left, and let the rightmost bit to be off. Here is the syntax how it can be used. Let me show you first the approach which is used to convert numbers from one system to another, and then I will explain more how to use those binary operations. There is a universal rule for number system conversion, okay, which is given here for any numbering or positional number system. So you can use this rule. It can be applied without any problem. So for any positional numerical number, whether it's in binary with the base 2, in decimal, which is the commonly used with the base 10, in octal with the base 8, and hexadecimal with the base 16. So you take the digits as a coefficient, okay? You take the digit as a coefficient, which is represented as bi, okay? And then you have the weights, which is represented as a ai. And then the a here will be representing the base, okay, through which you are representing the number you want to convert. And then the I will be representing the positioning index of the digits from 0 to the most higher power. So here is the formula. So you start by the most higher index power number, and then until you reach to 0. So for example, when you take for example a number like 14, 45 in decimal, you can represent it as, you can see that. So if I want to represent that in another base, for example, like binary, I have to take here b will be the 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 most highest, okay, coefficient value. So with, I have 4 like this. So I will take 4, okay, that will be multiplied by 10 to the power of 1, right? Because I have to start counting from 0, plus 5, that need to be multiplied by 10 to the power of 0, which will be 4 multiplied by 10 plus 5 multiplied by 1, and then will give me 45. So this is basically the way we have learned, okay? The conversion of number in decimal system. So I will now show that how Python deal with this notion we have already learned since primary school. So we'll see how we can teach the computer to do that on our behalf. So to avoid confusion most of the time, because this 45, depending on the positional numerical system based, it can have different meaning and value. Like this 45 in decimal will be equal to 45 because the base is 10. So I have to mention like this. But this is different to 45, for example, to the base of 8. The value will not be the same. So to avoid confusion, most of the time we have to provide the numerical system in which we are operating. Okay. So we have to tell to the computer as well to identify that. By default, we are operating in a decimal system. So this 45 in the decimal system, when we would like to get the same number in octal system, it will be equal to 55. In hexadecimal with the base 16, it will be 2D. And then in binary, to the base of 2, it will be 101101. Okay, let's check that. In Python, for example, for you to check that, you can use this approach. I will do that quickly. So for example, when I use int, I've shown you that you can use int to cast the type of a variable. When I provide two parameters like this, I provide it as a string character. Okay, I take this string character 45. This, the second value, is the base. Okay, when I hit on the button enter to confirm that instruction, you will see the Python interpreter will understand that this uh, 2 digits 4 and 5 in the base 10, in decimal it will be an integer number of 45. Okay, if I do the same in another base, look at this 8, you will see the value of 45 in another base like octal, it will be 37. If I do it in hexadecimal, it will be 69. If I do it in binary, like 2, you will see here, it doesn't accept that for binary. I will explain how to get the binary because the binary here, I will not use this approach. The binary accept only 0 and 1, but me, I provide decimal number digits 4 and 5. The binary accept only 1 and 0. So this was just to point out the difference in terms of representation of number. If in your logic you are intending to operate in binary, but you provide decimal representation in the decimal system, you will not get the expected output. So be aware of that. So for example, for me to get the equivalent of 45, okay, which is in decimal 45, in octal base 8, I have to provide the equivalent number is 55. The 55 in octal will be equal to 45 in decimal. And then when I change in hexadecimal, this will be equal to this 2 and D character. So this will be providing the same value. And in binary, look at now, I have to provide the correct representation of the values, because in binary we have only 2 digits to represent values. In decimal we have 10 digits from 0 to 9. In octal we have 8 digits from 0 to 7. In hexadecimal we have 16 digits from 0 to 9 and A to F. Okay, letters. When I put here, look at here, A101101. This is the equivalent of 45 in binary. So for us to do operations in binary representation values, we have to use bitwise. This is the application of the universal formula I've mentioned to convert values from one system to another. For example, here you have 45 in decimal. So I've already explained this. So in octal, its equivalent is 55. This should be represented as a 5 to the power of 8 to the power of 1, the most highest index. And then we take the second digit 5 multiplied by 8 to the power of minus n minus 1. So that will be 0. You will take here 5 multiplied by 8, it will be 40 plus 5 multiplied by 1 will be 5. That will be 45. Same for hexadecimal. You take the most highest digit, you have 2 digits, 0 and 1 index. And then you take the base is here is 16. 16 to the most highest index is 1. 1 multiplied by 2, and then plus d multiplied by the base is 16 to the power of 0. Then you calculate, it will give you this. Binary, same. The most highest bits will be 0, 1, 2, 3, 4, 5. The most highest index is 5. 2 to the power of 5 multiplied by 1. Then the next one will be 0 multiplied by, this will give you 0. And then this one will give you also 2 to the power of 3. It will give you 8. Then plus 4. Then plus 0. Then plus 2. Then this will give you 45. This is the way we have learned how to change the base of numerical representation. So I provided a table that gives you the correspondence between decimal numbers and binary numbers using 4 representation digits. If they say that you have to represent the number in 8 representation digits, just add zeros at the beginning, 4 zeros like this. 0 zeros. So this is 8-digit representation. If they tell you that you have to represent it at the 16 digits, use 4 blocks of 000 to represent a number. So here is the binary representation using 4 digits. So 0 in decimal will be represented in binary as a 000 4 times. 1 will be 0001. 2 will be 0010. 3 will be 0011. 4 will be 0100. 5 will be 0101. 6 will be 0110. 7 will be 0111. Basically, this is the work the computer does. When you provide a numerical number, it always convert them in binary. And then 8 will be 1000. 9 will be 1001. And then 10, 1010. So for us now to represent that, as I've mentioned here, you can check how to convert the the system from octal to decimal. Here you have integer. The octal can be represented from the 8 digits from 0 to 7. So 7, 5, and 0, they are in the domain. So you can represent them. It will accept, the interpreter will not detect as error. And then this represents the base. As I've demonstrated, this will give you 40. So when you go here, you do this, you have 50 in decimal will correspond to 40 in octal. Okay, so be aware on which base you are operating on. 28 will be representing 40 in hexadecimal. Okay, then in binary you have 1 0 1 0 0 0 3 0 in binary. It will be providing 40. So when you do computation, be aware on which system you're operating on. Same for this one. You can use that one. So just as a reminder, you take the coefficients, and then you multiply by the base to the power of the most highest index to start on, and then the next will be the coefficient of n minus 1 multiplied by the base, okay, to power of n minus 1. Since here we are in the binary, the base here will be always 2, and then we'll be decreasing the index until we reach 0. So the start always counting the index from 0 from the right to the left. Okay. Like here we have index here is 0. I will change the color. We have the index, we count from right to the left. 0, 1, 2, 3. Then the first coefficient will be taking b is 1 multiplied by 2 to the power of 3. That will give 8. Then the second coefficient will be 1 multiplied by 2 to the power of n minus 1. 3 minus 1 will be 2. That will be 2 to the power of 2. It will be 4. And then 0 multiplied by 0 with the base 2 to the power of 1 until we reach 0. This will be 8 plus 4 plus 0 plus 1 will give 13. So to get that, you can check also in the Python interpreter in integer. Then you take 1101. This will give you 13. Okay. I hope it's clear for everyone. So now let me explain the bitwise operator. For the bitwise operators, like the AND operator, we are operating on the bits. So in this table, you will see what does the bitwise AND operator. It return 1 if both bits are 1. Here, 0 combined with 0. So the expression will be A domain will be 0, 0, 1, 1. And then B 0, 1, 0, 1. So the expression of A and B will be giving 0 if A and B are 0. If B is at 1, A at 0, it will be giving 0 because both are not 1. It will give 1 only when A and B are at 1, and the result will be 1. This is what we say the AND operator on the binary digits. Let's say I would like to do the bitwise operator, but using the decimal representation of values. I have A. To A, I assign 6, and then to B, I assign the value of 3. Then the results of the bitwise operator will be like A and B. This will be I didn't put the assignment. This will be equal to 2. Okay, so I did the bitwise AND operation on 6 and 3. So the result here you can see it's 2. So basically, it does, it converts first 6 in binary, representing the 6 in 8 digits. So you have 0, 0, as I mentioned. You have 2 blocks of 4 digits. So in the table, if you check, 6 represent 0, 1, 1, 0. And then 3 represent 0, 0, 1, 1. Then the result will be 2. applying the bitwise operations. So what it does this 0 and 1 equals 0, 1, 1, 1, 1, 0, 0, 0, 0, 0, 0, 0. And then when you check in the binary 0, 1, 0, it will give you 2 in decimal points. This is the way the CPU operates on the values we provide. And the interpreter also has to understand that. That's why we are learning this. With the OR operator, they say that it returns 1, at least if one bit is 1. You can see here 0, 0 gives 0, 0, 1, 1, 1, 0, 1, and then 1, 1 will give 0. So with the same example, we can now check here. We did the same. Let me change now the operation. Here is the OR operator. The OR operator is the key which is located on the top of enter key on your keyboard and below backspace. So click on that key. It will provide you this OR operator. Is almost close to the delete button if you are using the QWERT keyboards. Then when I check the result here, you will see the result is 7 for the OR operator, but for the AND it was 2. So what it does, it's just you do the operation of binaries. A, which is assigned 6, it's represented as a 0, 1, 1, 0, and then 3 is 1, 1, 0, 0, 1, 1, which correspond to 0, 1, it will give 1, 1, 1, 1, 1, 0 will give 1, and then this will be equivalent to 7 in decimal numbering system. You have the XOR. The XOR also here it return 1 if the bits are different. So here you have 1. When the bits are same, you have 0. 1, 1, 0. When at least one bit is different, it provides 0, 1, 1. This is the logic of this operator. The same example, you will get 5. If I go again here, I change the operations. So this XOR operator is the key 6 in capital letter. You go to your keyboards, you combine shift and 6 button, or you put your keyboard in capital letter by hitting the caps lock key and then use the 6 button. Okay, it will give you this XOR operator, which will be 5. The XOR operator on 6 and 3. The notes bitwise operator will invert all bits and return the 2's complements. Okay, it's like the same when we do operations in a decimal system. So here the 6 representation in binary will be the representation of 6 in binary, as I mentioned, will be 1, 0, 1, 1, 0. And then when we apply these notes, it will be the key just below escape. What does this operation? It will take the bits here, all the bits that were 0 before, they will be changed to 1, and the 1 to 0. Like here, you have 0, 0, every bit will be put to 1, and then all 1, 1 will be put to 0, 0. And then this will be corresponding to minus 7 in binary representation. So this is what does the notes operator, just changing the 0 in 1 and the 1 in 0. You have also the left shift. With the left shifts, you have to shift the bits to the left n position, okay? And then append 0 on the right. Like this, 6 is represented as a 0, 1, 1, 0 in binary. Applying, okay, this left shift 1 will be just shifting the bit to one position from the right to the left, okay? Like here, before I had 0, and then this 1 will be shift one position to the from the right to the left. You can see here, I have, let me show you now with this red color. You will see this has been shifted like this. This is what does the shifter, the left shift, okay? The one which was in binary at the end position will be shifted to the left. Like this shift will be giving 12 in decimal representation. I didn't test this one. This one was -7. It's correct. I already explained that. Now let me check the bits shift, the bitwise operator shift with A. So I have A, I have this shift 1, and then the result will be 12. Yeah, that's correct. Then for shift left, the shift left, the rule says you should take shift the bits to the right by n position, and then discard the rightmost bits. Okay, let's have a look. Here, the 6 is 0, 1, 1. I have to shift from the left to the right. So you can see here, same thing. I'm shifting like this to 1. So compared to the left, I shift from the right to the left, but this right shift, I shift from the left to the right. Okay. In this time, I do this, then the result will be 3. Okay. I hope it's clear for you. So in short, to summarize about the left shift and right shift, the effect is like the multiplication in decimal. When you have the left shift, it be equal to the multiplication. Okay, you have 6, that should be multiplied by 2. 2 is the base, and then for right shift, you take the number, you divide by 2. This is how you can calculate the right and left shift in decimal. Just divide by 2 for right shift, and left shift multiply by 2. This is the simplest way to address such kind of issues. In summary, we have covered the AND operator, okay, on the binary operations, and then the OR, then the nodes, and then the shifter, left shift, bitwise operator, and then right shift. So they are simple. If you just understand the rule I mentioned, they will be simple for you to understand. The left shift, just multiply the value by 2. The right shift, divide the value by 2. Simple. So as I mentioned earlier, they are used for many use cases in cryptography, in networking, and in some cases for flag and permission management, especially for the system level programming, like operating system. You may have some flags that need to be managed in memory for access control management. We use those kind of bitwise operation. We use also bitwise operations for data compression. They are most useful in such kind of cases. So after saying that, I want to cover now the association of the operators. Like we have learned in the algebra, in Python also, we do apply the same logic to associate now uh, operators in expressions that have more than one operators. So we have multiple operators in some expression that can be used for long and expression. We have to associate them based on the priority of precedence. So in case of multiplication operators, they have higher precedence, okay? And in case of other operators, they may have the associativity, which may be less important. We have to figure out what will be the case for each operators. For the multiplication, it has higher precedence for evaluation, but it's can be its associativity should be determined at uh, the other level of execution or evaluation. When you are facing a situation where we have two operators, we have to evaluate them based on the precedence and the associativity. I will elaborate on it in this table. We have several operators I've mentioned. So here you have the summary of the table that shows the association and the precedence of those operations. For example, parentheses are the most highest, okay, operators that that should be associated from the left to the right. You have, for example, indexes, okay, when you have a representation of a series of numbers. So the index in terms of subscription and slicing, they need to be evaluated from the left to the right. In some function like weight x, so those are kind of higher level precedence operations. I can just ignore that, starting from the number line number 4. Okay. In the other case, I will explain later again in which case we can be able to use such kind of operators. Okay. So now let me explain the operators we have mentioned earlier. For example, this one is the most highest, okay, precedence operator, the exponentiation. We associate that from right to left. And then we have this unary positive and negative bitwise. They can be also associated from the right to the left. You have the multiplication, division, floated division, modulus. They are also located at the level 6 of precedence, and they can be associated from the left to the right. You have plus and minus, same, uh, low precedence compared to division and multiplication. They can be associated from the left to the right. You have also those shifts at the level 8. The association is left to the right. Most of them left to the right, except this one, which can be associated from the right to the left. Notes X. Notes can be associated from the right to the left. You have also comparison operators here. They are located at the number 11, like this. So they are used also the association going from left to right. You have the bitwise and or, which are also associated from left to right. So for me to explain the priority using an example, you have a complex expression that has two operators. Which one should be processed first? So in terms of Python, we start first from this one because it has a higher priority as low precedence. And then we can take the addition like this. So first of all, this is a mistake. This is higher precedence. So not low. You have to correct it. I mistaken there. This means higher precedence, not low. Yeah. And then this one, the higher precedence operation will be first evaluated, and then the results will be combined with this because this one has a low lower precedence. This is the way Python will be processing or computing this expression. So the best practice when you do programming is to use parentheses, because parentheses can be useful to guide the interpreter in the logic you try to build. Because if you just provide it like this, it will be calculated like 20. It will first calculate this because it has a higher priority, and then add this, which can be different when you wanna implement that as this one first. If you wanna enforce that logic, you have to use parentheses. Otherwise, the expected result will be different. Like here, you have in this program here, we just provide those operators as they are mentioned there. So the Python will be applying this second approach, as I explained, in terms of priority, which is totally different if you would like to enforce this one, because the result will be different. So depending on the logic you want to implement, be sure to use the right ordering of operator in your expressions. In some cases, okay, you may be using the logical operators like if or and or. In such kind of situation also, is better to use parentheses to guide the Python in the logic you would like to implement. Like this, you have Alice, which is initialized with string name Alice, and then age is 0. If name is equal to Alice or name is equal to Bob and age uh, greater than or equal to 2. So you wanna uh, print welcome only if the name is either Alice or Bob, but this condition should be true for this instruction to be executed. Hello world. Otherwise, goodbye. If this one is false, if this one is false, you cannot uh, show hello world message on your screen. So for explicitity and readability, use parentheses like this. So you can first check these parts, okay? Alice or this mean at least if one of those two expression is true, and this one is true, because this is and, this instruction will be executed. If this one is false and this one is true, you will go to else. So the associativity for arithmetic operators, you have some operators has the same precedence, okay, as I've shown. But if they have the same precedence, you have now to assess the associativity, okay. So in this case, for example, they say that we can whether evaluate them from left to right or from right to the left. So in this case, again, here you have this associativity. It has a low associativity, but this one has a higher associativity. Both, they have the same precedence, division and multiplication. Then, in this case, we start first with the division, okay, because it has a higher associativity, and then we'll be doing the multiplication because it has a lower associativity. So we apply the LTR rule, associativity. So if you wanna implement a particular logic, be sure to provide the right representation of your association. So in this example, for example, we apply the left-right association. So this, when you implement it, Python will understand that as if you put parentheses like this. 10 multiply by 10 and then divide by hundreds. Same also for subtraction and multiplication. In this case, they have the same precedence, but different association. Okay, the associativity. In this case, they will start first with the highest associativity is plus, and then the lowest associativity by going from the left to the right. So this is the way Python will understand that. If, for example, you want to implement another logic like 5 minus 2, so enforce that logic by placing the parentheses at the right position. Otherwise, you will get another result. Same for the exponentiation. We do first try to evaluate this operator and this operator. They have the same precedence, but different associativity. So this will be evaluated from the right to the left. So depending on what you would like to implement as a logic, it will be affecting the way you should connect the operand and the operator in your expressions. So in terms of precedence and associativity, you can see here division and multiplication, both they have the same precedence, but in terms of associativity, you have to go from the left to the right. Plus and minus, same precedence. Associativity, you have to go also from the left to the right. So you give priority first to the operation which is on the left, and then the one on the right will be processed there. And then you have the division and multiplication. They have the highest precedence compared to plus and minus. So if you have to enforce a particular logic, use parentheses, okay, to force that. For example, in this sub expression, here you have 1, 2, 3, 4, okay, operators in one expression. In terms of priority, in terms of precedence, this one, division, will be the first to be performed because it has a higher precedence than plus and minus, because we go from the left to the right. And then it has the same precedence with the multiplication. In terms of associativity, they have a highest associativity. That's why we go from the left to the right. Then, secondly, will be performed the multiplication. Okay, and then will be performed the addition because it has a higher precedence than the multiplication, the subtraction. Then the subtraction will be performed as the last operation. So if you would like to enforce a particular logic, again, be sure to enforce that with parentheses. Okay. Okay, like this, for example, Python will understand that as if you do this 200 divided by 10, and then 3 multiplied by 10, and then this will be added with 100, and then the subtraction will be the last, which is totally different. Let's assume that you would like to enforce this logic. If you don't put parentheses like this, the compiler or the interpreter will be understand it as if it was like this to apply the rules I have mentioned. So be aware of that. For example, in this expression, you will see the output will be here like this, 90, which will be as if you provided parentheses like this. But let's assume that you would like to implement it like this. If you don't provide parentheses, Python will give you a wrong answer. So in terms of the logic of your program, it will not be correct, although you put all the necessary components, but in terms of logic, it will be giving wrong answer. I hope it's clear. So those expressions are different. Be aware of that when you build your logic. And then here you have also non-associativity. Okay, in some cases, you have to remember yourself that in Python, most operators have the associativity, which means they are evaluated from the left to the right or from the right to the left. Okay. So when you have the similar precedence operators, you have to use parentheses to enforce the logic you would like to implement. But in few operations, there are no associative. That means they cannot be chained, like in these cases. Like when you use the unary operation like this, you cannot chain them as we did in the other cases. You cannot change them. You may receive an error because I've shown you when I test one unary operation in the interpreter. Like this one, it will give you an error. Like you cannot change this one. The syntax is not correct.